this is a block diagram of a dozen regions of the auditory cortex. This is where the human brain processes sound information, what you're doing right now. And this has been modeled and simulated, and we've applied tests to the simulation, and we get the same results as applying to those same tests to human auditory perception. This is a similar model and simulation of the visual cortex, where we process visual information. And there's also a model and simulation of the cerebellum. That's where we do our skill formation. For example, catching a fly ball is done by the cerebellum. And this has been modeled and simulated and tested. And we always wondered, how does a kid catch a fly ball? Because in order to do that, she has to actually solve a dozen complicated formulas in a few seconds. And most 10-year-olds haven't taken calculus. But we actually now understand that the cerebellum actually does solve those equations in a couple of seconds, and it does it without our being consciously aware of it. And we've actually modeled and simulated that process and tested it. And there's actually a model and simulation of a slice now of the cerebral cortex, where we do our abstract reasoning. As you're now trying to follow this lecture, you're using your cerebral cortex, and that, at least a piece of that has been modeled and simulated. So all of this is scaling up at an exponential rate. These models and simulations are getting twice as powerful every year. I make the case in chapter 4 of my book that within 20 years we will have models and simulations of all the regions of the brain, and they will provide us with the software to create intelligent machines. It will also provide us more insight into ourselves. That's been the goal of the arts and sciences for thousands of years. And these intelligent machines won't be an invasion of intelligent machines to compete with us and displace us. They will make us smarter. That's what we've always used our tools for. Ever since we picked up a stick and extended our physical reach, we've been using our tools to extend our reach and make us more powerful physically and mentally. We can now take a device out of our pockets and access all of human knowledge with a few keystrokes. That makes us smarter. Very few people could do their work today without these mental extenders that our computers provide. And ultimately, we're going to put these devices inside our bodies and brains and make ourselves healthier and smarter. And that's really what the human species is all about. All of this is driving economic growth. If you look at gross domestic product in the United States, but also everywhere else in the world, you can hardly see the recessions. When they happen, they're painful, and people are very concerned about them, but they're very little ripples if you look broadly enough. Even the Great Depression in the United States and much of the rest of the world in the 1930s, you can see a dip, but the curve snaps back to where it would have been had it never occurred in the first place. And the same thing will happen with the economic crisis that's happening right now. And the progress of information technology, this exponential growth, will continue through the current crisis without any effect at all, because that happened even during the Great Depression and every one of the recessions we've had since. Productivity, the value of an average hour of human labor has increased at an exponential rate. It was $30 in constant American dollars 45 years ago. It's $130 today. And the adoption of these technologies is also exponential. This is e-commerce on the internet. It has grown exponentially. It's now $2 trillion, and it's continuing to grow even in the current crisis. And it's well on its way to being the largest nation in the world, if it were a nation, but it actually doesn't respect national boundaries. And you might say, now wait a second, wasn't there a boom and a bust in these dot-coms, these e-commerce companies around the year 2000? How come we don't see that? That was a investment community phenomena, not an adoption phenomenon. The adoption of the internet and e-commerce was very smooth and exponential. The investment community, Wall Street in the United States, looked at the internet in the 1990s and said, wow, this is going to change everything. This is going to take every business model and turn it on its head. That was true, but it wasn't going to do that overnight. So the investment community came back 3 years later in the year 2000 and said, gee, it hasn't changed everything. I guess we were wrong, and all the values went the other way. But meanwhile, it was continuing to grow. And this phenomena of a boom and a bust is actually an accurate predictor of what ultimately are very profound transformations. It actually happened in the railroads in the 19th century. And education is growing at an exponential pace because, I mean, there's often concern we're destroying jobs. And yes, we're destroying jobs at the bottom of the skill ladder, but we create new jobs at the top of the skill ladder. And so the skill ladder moves up. And so we invest more in education. We had in the United States 50,000 college students in 1870. We have 6 million today. Around the world, 10 times as much is being spent per student in constant currency on K through 12 education. So we are investing more in education to keep up with the rising skill ladder. And we're actually creating more jobs at the top of the skill ladder than we're destroying at the bottom of the skill ladder. And the new jobs pay 8 times as much in constant currency as the old jobs. So this is actually a positive progression. And I mentioned solar energy. I mean, this is a graph here on a logarithmic scale of the amount of solar energy in the world. And this is a smooth doubling, not every year, every 2 years, but it's only 8 doublings away from meeting all of our energy needs. And very often when these phenomena are at 1%, people dismiss them as not important, and they ignore the exponential progression. But very quickly, 1% becomes 2, 2 becomes 4, and 4 becomes 8, and ultimately this will be a major contributor to our energy. And what's fueling this is that the cost of solar energy is coming down rapidly, as we're using new technologies like nanotechnology to apply to more efficient and low-cost solar panels. So let me show you one more technology that we've created in our own laboratories, and then I'll draw a few conclusions, and then hopefully we have some time for some questions. One of my companies created the first speech synthesis in the 1970s, and that was part of the first reading machine that we created. In the 1980s, one of my companies created the first large vocabulary speech recognition. Both of these technologies have been in continuous development, so we took the latest version of them, and we added language translation and created a translating telephone, which would automatically translate from one language to another from spoken language. I showed you earlier the ability to translate from one language to another with a written document. This is doing that from spoken language, and I've used this to speak to people around the world. This is a demonstration,
Dies ist eine Demonstration
of a prototype of a quote translating end quote telephone. Period.
von einem Prototyp eines übersetzenden Telefons.
Within a few years,
Innerhalb einiger Jahre
we will be able to talk to anyone,
wir werden fähig sein, zu jemandem zu reden,
regardless of their language. Period.
ohne Rücksicht auf ihre Sprache.
The rain in Spain,
La pluie en Espagne
stays mainly in the plain. Period.
reste dans la plaine principalement.
Merci pour votre attention. Period.
Thank you for your attention.
So, sorry I don't have Spanish, but it does work in about 13 languages. So as we get to early in the next decade, computers are going to disappear. They're already getting very small. They're in our pockets. They ultimately will make their way into our clothing, into our belt buckles. We'll be online all the time. We won't carry around displays to look at. It's actually pretty awkward to look at a movie on a device this size. We'll put them into our eyeglasses. They'll beam images directly to our retinas, and they'll create virtual displays that hover in air. Prototypes of these devices already exist. They can detect your head motion, so as you move your head, the image stays fixed. It can overtake your whole field of view and put you in a full immersion, three-dimensional virtual reality environment. We'll also have augmented real reality, so you see real reality, but you also see virtual reality at the same time. So as you look at someone, there'll be little pop-ups in your visual field of view that remind you it's their birthday next Tuesday, remind you what their name is, give you information about buildings that you look at.